into the unit circle and how we work with degrees, and then how we're going to work with something what are called radians. What else is going to happen is that within these next couple of sections, we probably will not be using calculators.
Does that mean there's going to be a
There's a big chance of that, my friend. So you guys understand, as we get into this a little bit more, this is when the calculator stuff kind of pulls itself aside for a while. We'll discuss that as we get into this a little bit further. So what I want to do to start with this is talk about angles like you know them now. We all know that angles can be acute or obtuse, correct? Right, straight, any of those. We also know that if you have a quadrant, that's your 4 quadrants, correct? All right. Here's what we do when we're talking about angle measures in, basically this is starting up another unit of trig. What happens here is that you have 2 sides of an angle. That's how you make it, correct?
Yes.
Correct.
Okay. One side always starts here, at your 0. The other side moves up this direction, and this side is called the terminal side. And your angle in here would be theta, if you will. Okay. Now, depending upon how many degrees are in your angle, your terminal side could lie within a couple of different, could lie in any one of the quadrants. Or it could lie on an axis. Do you agree? If I measured 180 degrees, where do I lie? I lie on an axis. Which one, the x or the y-axis? The x-axis. If I measure 210 degrees, what quadrant would I lie in? 3. Very good. So what's happening here is that your angle measurements can lie within any of these 4 quadrants. Real easy example. If I say this one here, 60 degrees. 60 degrees would start at 0, move itself up 60 degrees, and it's in quadrant 1. You remember from way back in the day, if you're out the 1 stuff and you guys would label quadrants, you use Roman numerals?
Yeah.
It's the only time you ever use it? Correct. Okay. That's when you would, it's about the only time you ever use Roman numerals or Rocky movies or Star Wars movies. That's about it. Super Bowl. But I'm going to change this a little bit different now. Is let's say we have something that is 500 degrees. Where would that go? You're spinning around, aren't you? You're doing it though, you're doing that. If I say it's 500 degrees, we start again here, 90, 180, 270, 360, was that 450? So it's gonna be over here at 500 degrees. Here's what happens. Yeah. That's what you're looking at. What happens here is when you want to find out what quadrant in the terminal side of an angle is that's 500 degrees, this is your 0, 180, 360, 450, 500. And it's in quadrant 2. You're spinning yourself around through the quadrants. Okay? You're spinning yourself around through the 3 quadrants. So you have quadrant 1, 2, 3, and 4. Does that make sense? Notice how you're going to go counterclockwise for positive. In what direction do you think you're going to go for a negative? The other way, clockwise. If I want to say negative 100 degrees. If I want to draw negative 100 degrees, I'd start at my 0 and I'd go the other direction. And I would be in which quadrant? Quadrant 3. What's that? Yeah. moves the dot. Okay. Now, what I want you guys to see here is that the direction of way that your angles go will help you figure out what quadrant they're in. Now, the idea that we use this for is to eventually start to talk about what's called coterminal angles. Let's look at that. Coterminal. What I want to do here is draw two angles. I want to draw 150 degrees and 510 degrees. We just did an example of 500. It wound up in what quadrant? 2. Okay. So if I go woo, woo, and say that that's 510. Correct. What happens here is that 150 and 510 are what they call coterminal because the terminal side, the ending spot of the angle, is in the same position. It just so happened one of them got spun around one more time to be there. So the other angle, these two guys would be called coterminal. All right. Two angles that they call in standard position that share the same terminal side. In order to figure these things out, you know, whether or not angles are going to be coterminal, it's just a matter of like you just said, Jason, it is adding or subtracting 360 degrees is really all it is. Okay. So if I want to talk about a coterminal angle of 45 degrees, I want to talk about a positive coterminal angle that's 45 degrees, or that's coterminal width, excuse me, and a negative angle that's coterminal width. I'm basically adding 360 and subtracting 360. Take a look. 45 degrees is right here, correct? Everybody agree to that?
Yeah.
All right. Now, if I start from this spot and I go around again, I'm adding 360 degrees to that, but I'm also to that that 45. What was it? Okay. Now, if I'm going to go the other direction, if I go this way, what's the negative? Negative 3 what? 315. Everybody okay with that? You're basically adding and subtracting 360 degrees. Okay. Why we talk about it in terms of degrees first is because you guys all know that going around a circle is 360 degrees, correct?
Yeah.
Isn't that the circumference going all the way around? How do you measure that in terms of pi? 2 pi r, right? Okay. So you know that the circumference of the circle is basically, if the radius is 1, it's 2 pi. Am I right with that? That's where unit circle comes into play. And that's where we're going through. Let's talk about this. When we have our quadrants, our axis, we have 360 degrees to go around in the circle. Everybody agree? We've said this many times. To go one full revolution is 360 degrees. I know that this spot here is 0, 90, 180, and 270. I also know that if I start at 0, oh, sorry, this is 360 then at the end. If I'm saying that my radius of my circle is 1, to go one full revolution in terms of the circumference with pi in it, it would have been 2 pi. Everybody agree? So 360 and 2 pi would be considered the same amount. 180 would be considered the same amount in terms of pi as what? As just pi. So 180 is the same thing as pi. What would 90 be? Half pi. Pi over 2. And what would 270 be? Very good. 3 pi over 2. Everybody see that? you getting those numbers? How are you converting that degree into terms of pi? What did you do for each one of those? Think about the algebra you just did in your head. You actually did a one-step algebra equation in your head. Okay, all right, I see what you're saying. Okay. Now, what would I say? What would you do if it was 30 degrees? What would be 30 degrees in terms of pi? Very good. How'd you get that? Very good. What you're doing here, ladies and gentlemen, is we are now talking about what's called radians. In your calculator, there's a button that converts things to radians. It says RAD. But those radian measurements will never come out as exact answers, as what we call in terms of pi. Radian measures are the same thing as degrees, but in a different form. It has pi in the answers. You'll never use the radian button on your calculator, because what we're going to be able to do here as we start to use more and more of this, what we call the unit circle, you're going to be using everything in terms of pi. So like I said, the calculator kind of goes away. So what I want to do here is just kind of walk through with you guys a couple of the standard, what do you want to call them? The standard degree measurements and how we convert them into radians. Now what I did is I made a nice little circle for you. I forgot the hole punch it, so I'm sorry. That way you guys can have a nice little chart that you didn't have to worry about drawing. What's that? Yeah. Saves time. So let's take a look at this. I think I got a clean picture of that.
Unless the picture you gave us like 6.
No, you don't have to do all of that. Why should I ever count, right? Have you guys figured that out yet? I thought I had this on. Oh, there it is. So basically right now you guys have something like this in front of you. Right? Now, we've already talked about being at 0, 90, 180, 270, 360. So this was 2 pi. This was pi over 2. This was pi. And this is 3 pi over 2. The other angles that you're going to work with are always going to be built off of your special right triangles, 30, 60, 90, and 45, 45, 90. So the other angles are going to be 30, 45, and 60. Everybody okay with that? Going up in order like that? Now, today I think I might just worry about the first quadrant as far as how this stuff is worked with. Now, you already said that 30 degrees in terms of radians was pi over 6. What do you think 45 will be? Pi over 4, because it's half of 90. Everybody see that? And what would 60 be? 3. Pi over 3, very good. So what's happening here is you are actually converting degrees into radians without using any formula besides this. Take angle in degree, divide it by 180, and slap a pi next to it. Works every time. 30 divided by 180 is 1/6. Slap a pi on it. Pi over 6. 90 over 180 is 1/2, pi over 2. 45 over 180 is 1/4, pi over 4. You guys are doing that in your heads by working through, all right, 45 is half of 90, therefore half of pi over 2 would be pi over 4. 1/3 of 90 is 1/3 of pi over 2 would be pi over 6. You guys are doing those quick calculations in your head, but yet there's a very simple way to do it. All right, not bad? All right, well, let's see then. What I want you to notice is these middle points are always in terms of 45 degrees. So to jump from 0 to 45, 45 to 90, you're adding 45 degrees each of those parts. What's 45 degrees more than 90? 135, okay. Add 45, you get 180. What's 45 more than 180? 225 is here. You get to 270. What's 45 more than 270? 315. What you did is you just got, basically you got the 45 degree angles going all the way around the circle. Bless you. To go to the next groupings, you're going 30, 60, 90. What's happening each time you go up with those? All right, so what's the next one? 120, 150, 180, 210, 240, 270, and 330. Is everybody okay with that? Do you think you could figure out the radians of those then, in terms of pi? Take a second and see if fill in the try and fill in your radians on these and see how you do. We'll check it in a second.
No calculator?
Yeah, try and do it.
Oh, no.
Try not to use your calculator with that. Try not to use your calculator. Use the premise of that you know how to do math.
What are we doing?
Yes, you do. Watch.
Can't you 200 or 360 divided by 2 down there?
Watch this. Is this 1/6? That's 1/3, right?
Yeah.
What isn't that 2/6? Isn't this 3/6? Would this be 4/6? This would be, because that's 6/6. Wouldn't that be 7/6? 8/6? 9/6? You guys know how to do fractions. Trust the fact that you know how to add fractions. You okay, Zoe?
Yeah.
You're just going, oh my God, I can do this, or just, oh my God?
I don't know.
Did you see how I did that? I'm using the common denominator here. 6, this is 1/3. This is the same thing as 2/6. 3/6. All I'm doing is just not simplifying it in my head, because I can write that out and redo it. You doing the other ones, Paul?
I was just thinking if 90 is 3/6 and then you keep counting it in the way that you were. What is the 135?
Okay, that's 135 is going to deal with the 45s.
Right.
So that's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Yeah. Exactly. It's not that bad, is it? You just have to remember, if you're dealing with the 30 and the 60s, you're dealing with 6. And if you're dealing with the 45s, you're dealing with it in 4ths. And remember, you're still, when you're on your axis, where it's 90, 180, 270, all of those fractions, whether it's 3/6 or 2/4, still going to simplify to 1/2. They're all proportional. They all have the same common ratio. All right. So again, this was 1/6, 2/6, 3/6, 4/6. So that's 2/3. So it's 2 pi over 3. This was 3 pi over 4. 2/3. 5 pi over 6. 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, this would be 5 pi over 3. '45s, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Yes, sir.
Why are those all over 6, not 3?
I'm simplifying it. When if you're writing that 1/6, that's 2/6. 2/6 simplifies to 1/3.
Oh, whoops.
3/6 is 1/2. It's just, I mean, what'll happen over time, if you remember it, is every time you're going up 30 degrees, you're going up 1/6.
So it's 6, sorry.
Okay. Not so scary, is it?
It's 305 pi over 2.
Yes. All right. Now, what happens here is that this goes both directions. Converting from degrees into radians, divide by 180, slap a pi on in the numerator. Yes, sir.
What's 330?
11 pi over 6. Okay. Now, to go the other direction, if I wanted to go from radians to degrees, I'm very good. You multiply by 180 and divide it by pi. And that will eliminate, it will switch you back into degrees. There will come a time that, you know, a problem like, say, do this in degrees, they'll give you your answer, they'll give you information that starts in radians. And there'll be times that you'll start in radians and it'll ask you to go into degrees. The unit circle is probably one of the most important things that we will work with in Algebra 2. I'm not going to lie to you, this is probably one of the biggest things you guys are going to take with you as you go into pre-calc and into calculus with all the trig stuff that you do. Because everything we do from here on out is going to be based upon these values. Yes, sir?
For the radians to degrees, will we be allowed to use calculators for those, or?
Well, what'll happen with radians to degrees is that you'll have the following. What is 3 pi over 4 in degrees? Well, you should be able to do that without a calculator, because you take 3 pi over 4 times 180 divided by pi, and you're just simplifying it out. It goes. 90, that's 44 across. Okay? You'll have to be able to do that. Does that make sense? Now, if it was one of the weird ones, you know, it's going to give you some really oddball value, yeah, then you'll have calculator. But for a lot of times, it's just something that fast. You guys never learned fractions like that? Did you have any idea what I just did? Okay. Let me show you what I did here. When I see you two just kind of laughing and shaking your heads, I'm all right, let me show you exactly what happened. When you're multiplying by 180 and dividing by pi, what this means, I can write this as 3 times 180 times pi over 4 times pi. Oops. Pi over pi is 1. Everybody agree? That's why that drops out. 4, all right, I'll make it even easier. What's half of 4?
2.
What's half of 180? What's half of 2? What's half of 90? What's 45 plus 45? Plus 45. That's what I did. All I did, guys, was just quickly simplify. All right? Yes, sir.
I think for the non-calculator portion, you should give us the stupid calculators, just in case we don't know how to add and subtract.
I might, but we'll worry about that when the time comes. Okay? We'll worry about that when the time comes. So, let's see. Oh, today's not Wednesday. I thought we were leaving in like 4 minutes. I was ready to say, all right, let me just give you this and.
No, that's, you're good. You should.
Where was I here? So we've done all this. So here's some oddball ones. What'll happen here, if you're converting from degrees into radians, you will always leave it in a fraction form with pi in your answer. We will never ever hit the button that says pi on our calculator because that is not going to give us what we call an exact solution. You probably dealt with exact answers a lot of times last year when you worked with circles and when you worked with spheres for surface areas and volumes and stuff like that. You probably had it all written out. So if I want to convert 110 into radians, again, 110 divided by 180, and slap a pi next to it. How do you simplify 110 over 180? Take the zeros. 11 pi over 18. That's it. Okay. If I want to convert negative pi over 9 into degrees, suggestion that I will make, if they give you anything that's negative, put the negative symbol in your numerator. A lot of times students tend to forget what happens. They forget that it's there. Just put it in the numerator. Multiply it by 180 and divide it by pi. Pi over pi is? So I have negative 1 up top, so I know I'll have a negative. And 9 goes into 180 how many times? 20. Your answer is negative 20 degrees. What quadrant is that in? Okay? 4. Good. What would be a coterminal positive angle with negative 20? What is it? 340, very good. What would be another negative from that? Very good. Very good. All right. We're adding and subtracting out some stuff. So, Mama, you all right? It's just math.
I know. It's fun. I love it.
Your sarcasm doesn't work.
No, that's serious. I love it. It's
I think you were doing this in your trick stuff for
3
MSEC.
hours last night.
Would have been easier if you knew how to do it, right?
No, we're past this. We're on the.
Are you solving equations already?
No, we're graphing sine and cosine,
Okay.
which is so much fun.
You done tangents yet?
No, yeah.
Have you shifted anything yet?
We started shifts last night.
Wait till you shift some tangents with your weird, yeah.
I was looking at a brick wall yesterday.
Swing by, I'll show you. It's easy. Let's just call it on this. There's other things we're going to do with radiant stuff here. We can finish that up tomorrow. But like I said, if you don't have this already copied down correctly, please make sure you write this one out. It's verbatim out of your book. The unit circle, like I said, is probably the most important thing that you will take from this class. Next year with Mr. Thames or Ms. Denny or whoever else is teaching pre-calc, you walk, if they ask you what is the parts of the unit circle, if they jump right into it. If you don't know some of these things, they will come after me with a stick.
An art stick or
Just a stick and just beat you. Yeah, a meter stick. Because the rest of the world doesn't deal with degrees, just like the rest of the world doesn't deal with English measurement. The rest of the world is in radians, because the rest of the world is rad.
I think we should watch that movie.
We should watch that. Let me give you a couple of these problems to try out for tonight. What I'm going to have you guys do is basically some simples. What I want you guys to do tonight is we're going to find coterminal angles only in degrees. And I'm going to have you do some conversions between degrees and radians, just for real basic practice stuff. Tomorrow, what we're going to do is we're going to start focusing solely upon radians. We're going to learn how to draw things in terms of pi. How do we draw up angles that are in radian measure? How are we going to use radians as far as finding coterminal angles? And we'll probably start talking about what you might have heard before, something called a reference angle. We'll probably start talking about that in terms of radians as well. So this stuff is mainly, these first four are all coterminal, positive and negative with degrees. The next grouping is nothing more than converting from degrees into radians or from radians into degrees. Try your best to do the conversion parts without your calculator. Try and do it without. Yes, sir.
It looks like we're kind of running out of book. What are we gonna?
Remember, we skip around a little bit. We go 13, yeah, we go 13, 14, then we're going to go back to 10.
Okay.
We go 13, 14, 10, 11, 12. Maybe. And then we might start doing some pre-calc.
What are the chances of that?
Pretty good. No.
Yeah, we could watch that.